Imagine spending millions of dollars to build, the world's smartest, most creative artificial intelligence, only to realize you have to lock it in a cage of like 1990s style if-then rules just to stop it from endlessly talking to itself.
Right, which is wild to think about.
It is. Welcome to the Deep Dive. I'm your host, and today's mission is to decode the absolute loudest buzzword in the tech world right now, agentic AI.
The big one. I'm excited to get into this.
Yeah, me too.
Yeah.
So we are pulling from a really detailed video series and an in-depth article featuring 3 experts from McKinsey. That's Michael Shuey, Dave Kerr, and Stephen Zhu. And our goal today for you listening is to basically cut right through the Silicon Valley hype cycle.
Because there is a lot of hype right now.
Oh, so much. We're going to figure out exactly what agentic AI actually is, why the underlying architecture is fundamentally different from the chatbots you're already used to using, and how it's actually going to reshape your day-to-day work.
Yeah, because we aren't just talking about, a slightly faster language model here. We are looking at a completely different paradigm of how human intent translates into actual digital action.
Okay, let's unpack this, because the research opens with a pretty wild prediction from Michael Chu. He predicts that in 12 to 24 months, we might actually stop talking about AI altogether.
Wow, just entirely.
Entirely. Not because it was a fad that disappeared, but because it is going to fade completely into the background of everyday life, just like the internet did.
Oh, I see, like infrastructure.
Exactly. I mean, you don't consciously think about network protocols when you look up a restaurant on your phone. You just find the restaurant. His prediction is that AI will become exactly that invisible.
What's fascinating here is why that fade into the background is physically going to happen. It's not just adoption. It requires a profound transition in the software itself. The technology is evolving from a tool that merely talks to you into a system that actually acts on your behalf.
Right, so let's really establish the mechanics of what that means. If you follow tech at all, you already know the basics of standard large language models, or LLMs. We've all used ChatGPT.
Sure.
And the model is trained to predict the most likely text response to your prompt. You ask it a question, and it generates a text answer based on its training data.
It predicts the next word, basically.
Right. It tells you what it knows.
Yeah.
But it stops there. It just sits on the screen waiting for your next move.
It needs you to drive it.
Exactly. So the sources break down this evolution using a house hunting scenario, which I thought was super helpful. A standard LLM can tell you the average cost of a house in a specific zip code. But an agentic AI takes that information and moves forward autonomously.
It takes the wheel.
Yeah. It tells you the cost, and then it asks, hey, would you like me to find some properties on the market that match your criteria?
And if you say yes to that prompt, the system isn't just generating more text, it actively leaves the chat interface.
Which is the crazy part.
It really is. It utilizes external tools. It reaches out via APIs to live real estate databases. It searches the current listings, filters out the ones that, don't match your budget, analyzes the remaining options, and brings you back a curated summary.
Wow.
It is executing a multi-step process across different digital environments without you having to sit there and guide every single click.
And the sources also point out something huge about accessibility here from Stephen Gill. This complex multi-step execution isn't happening through traditional coding.
No, no.
Like, you don't have to write a Python script or drag files into specific folders to trigger these actions. It's happening through natural conversational language.
Right. Plain English.
Yeah. The system retains memory, it understands your context, and you don't have to click a single button to trigger this whole cascade of web scraping and data analysis.
Analytically speaking, that shift from text generation to executing real-world digital transactions, it's a massive milestone.
It really is.
Because for decades, if we wanted a machine to do something in the digital world like update a database or trigger automated payroll software, we had to write explicit, rigid code for every single movement.
Step-by-step instructions.
Exactly. Now, we have neural networks that can parse a vague human intention, formulate a logical plan, collect information from the live web, and actually perform transactions in highly dynamic environments. They are pulling levers in the real world.
So I was thinking about this, and tell me if this analogy works for the underlying architecture.
Okay, let's hear it.
Using a traditional LLM is basically like having a brilliant, world-class librarian.
Yeah.
You walk up to the desk, you ask a highly specific question, and they instantly hand you the exact book you need. It's an amazing tool.
Right, super helpful.
But you still have to go sit down, read the book, figure out what it means, and decide what to do next.
Yeah, the librarian gives you the raw material, but the burden of execution is entirely on you.
Exactly. But agentic AI is like hiring an executive assistant. You don't even go to the library. You just tell the assistant your overarching goal. They go find the book, they read it, they highlight the three most important takeaways. They realize you need to travel based on those takeaways, so they independently log into your airline portal, automatically book your flights, and then clear your calendar for the trip.
That's a great way to look at it. The assistant takes on the cognitive load of the workflow, but if we look at the reality of the enterprise landscape right now, we have to separate that theoretical promise from practical reality.
Oh, for sure.
We are deep in a hype cycle.
Right, because if these agents can do all these amazing multi-step things, why am I still answering my own emails?
Exactly.
When you listen to the tech industry, you'd think these autonomous agents are already running Fortune 500 companies. But the McKinsey team points out, especially Dave Kerr, that people are making incredibly excited claims about agents seamlessly managing your entire inbox and calendar.
Which just isn't happening yet.
Right. Outside of a few narrow sectors, the real-world scenarios haven't actually changed much for the average worker.
The excitement is heavily outpacing the implementation. Stephen June notes in the research that the word agentic is entirely losing its specificity.
It's just a buzzword now.
Exactly. It's becoming a catch-all buzzword for literally any software update. Companies are getting caught in this hype bubble where they are building complex networks of agents just for the sake of saying they have them.
Like a massive PR exercise. Oh, we need to show our shareholders we are innovative, so let's build 4 custom agents to talk to your agents.
Right, and in the rush to build those multi-agent systems, they are completely skipping over the fundamentals of good design and ignoring the actual user's lived experience. They are deploying the technology without asking if the technology is actually the right tool for the job.
Which brings us to what Michael Toohey in the sources calls the hammer and nail problem.
Oh, this is a crucial concept.
Yeah, when you get a shiny new technology, suddenly every single problem in your business looks like a nail. But not every problem needs an AI agent. I want to ground this in a real example they use, which is credit scoring.
Right.
Banks have been doing credit scoring perfectly well for decades, using basic spreadsheets and strict business rule systems. It is literally just math based on your financial history.
Simple arithmetic.
Exactly. Dave Kerr argues that looking at a straightforward math problem like that and deciding to deploy a massive, complex billion-parameter LLM to solve it is like using a nuclear missile to swat a fly.
It's just massive overkill.
But wait, I have to push back on this a little bit.
Okay, go ahead.
Because as someone who uses this tech, isn't the whole appeal of modern AI that it's flexible and creative? I mean, it can understand nuance and context in a way a rigid spreadsheet cannot?
Sure, it's very adaptable.
Right. So if it's smarter than a spreadsheet, why are the experts explicitly saying we shouldn't use it for core business logic like credit scores?
Well, that flexibility is precisely the liability in certain contexts. To understand why, we have to look at a crucial distinction in computer science, the difference between deterministic and non-deterministic systems.
Okay, break that down for me.
A spreadsheet or a traditional software program is deterministic. If you put the exact same financial numbers into the formula, you will get the exact same credit score every single time, without fail. It is a mathematically provable, strict if-then environment.
It's entirely predictable.
Exactly. But modern AI, especially LLMs, are non-deterministic. They do not calculate, they predict based on probabilities. Because of that probabilistic nature, if you give an AI the exact same prompt with the exact same financial data twice, you might get 2 slightly different answers.
Because it's sort of thinking creatively, essentially.
Right, and that non-deterministic nature is fantastic if you want a natural, engaging conversation or if you are brainstorming marketing copy.
Where you want some variety.
Yeah, but in a business situation, especially where compliance, legal regulations, or financial accuracy are involved, creativity is incredibly dangerous. You cannot have a system that probabilistically decides to get creative with someone's mortgage approval.
Oh, man. Yeah, that would be a disaster.
You need a deterministic system that gives the exact same result every single time.
Okay, that makes total sense. Think about the spreadsheets you rely on every day. You absolutely do not want an AI hallucinating the math in cell B4 just to be conversational.
Definitely not.
So having established where agentic AI is essentially a nuclear missile swatting a fly, let's pivot to where it actually shines. If we want to see where this probabilistic, flexible nature is an asset, We have to look at messy human environments.
Customer service is the perfect example Chewy highlighted in the research. Customer inquiries are inherently unpredictable. People ask questions in messy natural language, often with terrible grammar, ranging from incredibly simple tracking requests to highly complex, multi-layered complaints.
And a traditional deterministic chatbot, the ones we all hate, just gives up and says, I don't understand if you don't use the exact right keywords.
Right, it's entirely brittle.
Exactly.
But an agentic AI thrives in that ambiguity. It can parse the messy human intention. More importantly, it can connect directly to a company's proprietary knowledge base via internal APIs, find the relevant policy, and actually take action.
Does this just quote the policy at you?
No, it can autonomously access the shipping system to send a replacement item or interface with the billing software to process a return. Crucially, these systems are designed with escalation parameters.
What does that look like?
Well, if an issue is too complex, or if the system's confidence score drops below a certain threshold, the agent automatically packages the entire context of the interaction and routes it to a human Tier 2 worker.
Here's where it gets really interesting. The sources, specifically Stephen Zhou, talked about applying this to the legal domain. Now, law is famous for being incredibly document-heavy, requiring associates to spend thousands of hours manually parsing complex information.
Very tedious work.
Right. So one team worked closely with actual lawyers to understand their specific daily workflows. They didn't just throw a generic AI at the law firm. They taught agents how to execute the specific tasks the lawyers were already doing.
The mechanism there is fascinating. Instead of a human lawyer spending 3 days reading through a massive merger agreement to find out-of-standard liability clauses, an agentic system is deployed.
Wow.
The system is instructed to read the 500-page document, compare every liability clause against the firm's standard acceptable language, flag any deviations, and draft a summary memo detailing the risks.
And the result was huge. By using human-centered design to map those specific processes to agentic systems, they reduced the end-to-end workflow time by 4 times.
A 4x reduction. That's incredible.
Right. A 4x reduction in time spent on a task. And think about the economic ripple effect of that. This massive productivity gain actually allowed the legal company to lower their prices.
Which is rare.
Exactly.
Yeah.
Which meant they could expand access to their services, taking on higher volume work that simply wasn't profitable to do manually before. It changed their whole business model.
But achieving that kind of transformation at scale across an entire global enterprise introduces a massive architectural challenge.
How so?
Well, let's say the marketing team builds their own custom agents to analyze campaign data. The legal team builds their agents for contract review. The supply chain team builds agents to monitor inventory.
Sounds productive so far.
Right! But if every business line builds isolated agents with unique, custom-coded connections to the company's databases, the organization accrues what software engineers call massive tech debt.
Oh, tech debt. That's those fragile, temporary workarounds that eventually collapse, right?
Oh, exactly.
Like, if marketing's agent is hard-coded to talk to the sales database, and then IT updates the sales database, the agent breaks. You have 50 different teams reinventing the wheel, duplicating data pipelines, and none of these isolated systems know how to securely talk to each other.
It becomes an unmanageable IT nightmare. This is where the research introduces the concept of the agentic mesh.
The agentic mesh.
Yeah, and the mesh is not just a superficial buzzword. It is a critical architectural feature. It acts as the central nervous system for the entire company's AI deployment. It provides a common back-end infrastructure, a unified way for agents to authenticate, access data securely, and share context.
So they aren't all flying blind.
Right. It maximizes the reuse of IT systems so you don't have 50 different redundant pipelines pulling the exact same data.
Michael Chewy uses an organizational metaphor to explain this that I really liked. He says, think about how a human company operates. You have human specialists, someone in planning, someone on logistics, someone facing the customer. The agentic enterprise of the future will look exactly the same. You will have highly specialized digital workers, a planning agent, a supply chain agent. But just like human workers need a shared company directory and a common language to collaborate, these digital workers need a shared technological substrate to let them coordinate.
That's a great metaphor.
But I have to ask, if we have all these highly specialized autonomous agents running around talking to each other across this mesh, how do we stop it from turning into a chaotic digital boardroom?
What do you mean?
Like, what prevents everyone from just talking over each other and generating massive amounts of useless data?
If we connect this to the bigger picture, that chaotic boardroom scenario is exactly why the mesh is a fundamental necessity. Without a centralized, carefully designed architecture to govern how these agents discover each other, verify permissions, and hand off tasks, you don't get a highly efficient digital workforce. You get systemic chaos.
Right.
The mesh is about building a scalable infrastructure that dictates the strict rules of engagement for the future of work.
Which brings us to the human element. Because if an organization is using a centralized mesh of invisible digital specialists to do the heavy lifting, how does your job change? What happens to the human worker when the AI is doing the executing?
Stephen Zhu in the research acknowledges that whenever a major technological innovation arrives, there are very valid short-term worries about displacement. However, the overarching assessment is that agentic AI will ultimately grow global economic productivity.
So we aren't all out of a job.
No, humans will absolutely still be gainfully employed, but the day-to-day reality of the tasks we perform will look fundamentally different.
We're already seeing this happen in software development, actually.
Hmm.
Dave Kerr points out that relatively straightforward coding tasks, like the initial scaffolding of a new application or compiling early research analysis, are now being passed off to LLMs at a very low cost.
The AI writes the initial draft of the code,
Yeah.
and that shift causes a profound psychological change for the human worker. In software today, everyone is essentially being elevated to the role of a tech lead.
Meaning, you aren't just sitting down and typing out line after line of boilerplate code yourself. You are reviewing the architecture the AI produced.
Exactly.
You are ensuring that the output integrates correctly with the broader system and verifying it meets the company's security standards.
You're managing the AI.
Right. And I really appreciate how the sources describe the emotional arc of this transition. There is this initial rush of sheer excitement when a developer gets their hands on an AI agent. It's this feeling of, wow, I can write so much code so incredibly fast.
The honeymoon phase.
Yeah. But that honeymoon phase is quickly followed by the mature realization of a true tech lead, which is that, as Kerr puts it, every single line of code is a liability. You actually want as little code as possible to solve a problem, because human beings eventually have to audit and maintain that code.
It's so true.
So what does this all mean? I want you listening to imagine your own job right now. Whether you are a marketer writing ad copy, a financial analyst building revenue models, or a project manager coordinating global teams. Apply that tech lead concept to what you do every day.
Take a step back.
Yeah, when autonomous agents start handling the heavy lifting of your daily tasks, drafting the copy, pulling the financial data, scheduling the check-ins, you are no longer the one out there digging the ditch. You become the site inspector.
The site inspector, I love that.
Your job is to stand back, look at the overarching blueprint, and make sure the machine dug the ditch in the exact right place, to the exact right depth, without hitting a water main.
That site inspector visualization is highly accurate. This transition represents a massive elevation of human skill. It moves human workers out of raw, repetitive production mode and firmly into quality assurance, critical thinking, and strategic alignment mode. Your value to the organization is no longer in doing the rote task. Your value is in your judgment.
But if humans are stepping back into these oversight site inspector roles, we have to talk about the risks of the machines doing the labor.
Right, because things can go wrong.
Yeah, because letting autonomous agents run wild in the background of your business, executing API calls and spending company money, sounds a little terrifying.
It is, and Michael Chu is very clear-eyed about these risks, which largely echo the risks of AI generally, but are magnified by autonomy. Because these models are non-deterministic and probabilistically generated, they can experience hallucinations.
Where an agent confidently states an opinion or a fact that is entirely fabricated.
Exactly.
Imagine a customer service agent deciding to invent a completely fake, incredibly generous return policy and confidently promising a refund to a very angry customer.
And the company is now on the hook for that hallucination, or the agent just being rude and lacking basic human empathy.
Yeah, that happens too.
The risks compound exponentially when you have multiple agents interacting within that agentic mesh we just discussed. You can run into what computer scientists call race conditions.
Okay, explain how a race condition physically happens between agents.
Imagine Agent A is tasked with booking a flight but needs budget approval. It pings the finance agent. Let's call it Agent B.
Okay, makes sense.
Agent B asks Agent A for the project code to authorize the funds. But Agent A's system is instructed to only release project codes once a flight is tentatively secured.
Oh.
Right. So Agent A re-requests the flight approval. Agent B re-requests the project code. Because they are autonomous, they get stuck in an endless ping-pong loop, endlessly reacting to each other.
Wow.
It technically functions like the software hasn't crashed, but it produces absolutely zero useful work, all while consuming massive amounts of cloud computing power and racking up a massive bill for the company.
Okay, but if the problem is agents running wild and getting stuck in loops, why not just build a secondary agent to watch the first agent?
Right.
Like a digital supervisor to break the loop.
Well, Dave Kerr addresses this directly, pointing out a massive logical flaw in that approach. The idea of agents checking agents sounds great on the surface, but from a methodological standpoint, you are using a non-deterministic system you don't fully trust to assess the safety and output of another non-deterministic system you don't fully trust.
Oh, wow. Yeah, if we actually trusted the language model to accurately and flawlessly judge the language model, we wouldn't need the safety evaluations in the first place.
Exactly. You can certainly use an LLM as a first line of defense to catch obvious formatting errors, but actually evaluating the quality, safety, and strategic alignment of autonomous work is incredibly complex. There still comes a point where you fundamentally require a human-in-the-loop evaluation process.
Which leads to the overarching mandate for companies adopting this technology from Stephen Zhu. Go slow to go fast.
Go slow to go fast.
He states that organizations absolutely must set up cross-functional risk committees, bringing together the risk management team, the legal team, and the technology team from day one. They have to build incredibly strict guardrails.
We are talking about using old school, rigid, deterministic, rule-based systems to monitor the AI.
For example,
For example, installing a hard-coded text filter that physically blocks the customer service agent from ever mentioning a competitor's name in a chat, regardless of what the AI decides is the optimal response.
and I just have to point out the deep irony here. The tech industry spent billions of dollars building these brilliant, highly creative, autonomous agents to save us time, parse messy data, and think outside the box.
Right.
And now, enterprise businesses are building massive corporate committees and wrapping these billion-dollar neural networks in old-school, rigid, if-then rules just to babysit them so they don't hallucinate a refund or get stuck in an endless, expensive loop with each other.
This raises an important question, doesn't it? It highlights why going slow to go fast isn't just corporate speak. It is the only viable path forward for enterprise adoption. The technology is incredibly powerful, but true productivity gains, the kind that actually transform a business model without destroying a company's reputation, only happen when the risk controls are as sophisticated as the AI itself.
The guardrails are what let you drive fast.
The rigid guardrails are what actually enable the speed.
So let's bring this all together. Agentic AI is moving us past the era of chatbots that just answer our questions into a new architectural era of autonomous systems that actually do things in the digital world.
Right.
It is going to turn all of us into tech leads, forcing us to manage an invisible mesh of digital specialists who handle the execution while we handle the high-level strategy and the quality control. Provided, of course, that we remember not to use a nuclear missile to swat a fly when a simple, reliable spreadsheet will do.
It is a fundamental shift in how we leverage computing power, moving away from human-directed software and toward goal-oriented digital partners.
But I want to leave you with a lingering thought. We
Yeah.
started this whole deep dive by unpacking the prediction that in 12 to 24 months, agentic AI is going to fade completely into the background of our everyday lives, just like the internet. We won't even think about the complex mesh of agents routing our requests. But if these underlying systems are inherently non-deterministic, and if they're naturally prone to getting stuck in endless race conditions with each other, what happens when the invisible background infrastructure of our daily lives is suddenly capable of hallucinating on our behalf?
A fascinating architectural tension to watch unfold.
For sure. Thanks for joining us on this deep dive. Keep questioning the technology around you, and we'll see you next time.